Hi everyone, welcome to my YouTube channel. Today I'll be walking us through how to configure a new material in Ansys, particularly when dealing with composites. So first, it is required that you carry out basic tests on the new material. In this case, an agricultural residue. So usually, these are some of the things that ANSYS will require for you to define a new material. So you carry out that test. In this case, you are looking at date palm seed. We carried out the density, we obtained the density of date palm seed and that of aluminium, which can be gotten from journals and other online repository. So after doing this, the density of the composite, the property of the composite is a function of the properties of the other of the base materials. So in this case, if we have 1% reinforcement with HC, it means we have 99% reinforcement with aluminium and 99% aluminium alloy. So the formula will be 0.99 times the value of aluminium plus 0.01, which is 1% of the total mass, times the value of the reinforcement. So that will give us the property of the composite. So the same thing all through for the other materials. So for the other properties, so just drag this across and drag this across and drag that across. So you can just take that all over. So let's assume you are dealing with a reinforcement of up to 15%. We have been able to compute the reinforcement, the property. So the next thing will be to configure these properties into Ansys. So we load workbench, Ansys workbench. Now Ansys workbench has fully loaded. So this is the project schematic area, and then this is the toolbox area, different form of analysis system here available. So, but in this case, let's try to deal with the static structure. So from the toolbox, click on static structure and drag to the project schematic area. So in this video, we are just going to look at setting up engineering data. Okay. Subsequent video, we can look at the geometry, model setup, and how to solve. So if you want to have that video, you can just drop a comment in the comment section. Don't forget to like the video. So here you can right click and then click on edit. So basically we like using a reference material in case you want to carry out a test on the particular material you want to check in Ansys, you want to do analysis on in Ansys. Just pick structural steel and see the properties displayed for structural steel. You can see Young modulus, you can see density, you can see Poisson ratio, bulk modulus, shear modulus, and all of that. These are the properties that you need to carry out structural analysis. So our material is not defined here, so we're going to define it. We're going to say A356 plus 1%. Let's use R for reinforcement. So we do that. And then this material does not have any properties. So on the left here, you have the properties. So from this, you either you double click that or you drag down. When you bring down the property, you can now type in the value. So ensure that you are using the right unit here. Ansys, okay. Ensure that you are using the right unit. However, you can quickly change. My unit here is gram per cm cube. So I can quickly change that to gram per cm cube. Then I type in the value. We are looking at this particular row, right? So density is 2.611. So 2.61661. That is the density. So we have done that. Then back to our material again. This time we will need to put Poisson ratio. Poisson ratio can be automatically calculated actually. If you have the tensile modulus and the shear modulus, you can calculate Poisson ratio. So that means you need tensile compressive strength, bring it there or double click. You need tensile yield strength. The same thing for a what do you call it now? For a brittle material, they are the same thing, right? So compressive strength, what else do we need? We will need let's look at isotropic elasticity. So that is what will give us the bulk modulus, the shear modulus. So there are different ways to calculate that. You can either use Young modulus and Poisson ratio. It will automatically give the shear modulus. So if you have your Young modulus and Poisson ratio value, you click on this. But if it is a bulk modulus, if it is the bulk modulus and shear modulus you have, or bulk modulus and Young modulus you have, you click on the one that you have. So let's see our data. What do we have? We have tensile modulus and shear modulus. So we have tensile modulus and shear modulus. Let's see whether we have that Young modulus and shear modulus, right? That's what we have. So we will put in the value of our Young modulus. For this case, Young modulus is 71.67. Also ensure the unit is correct. So here we are on gigapascal, so we click this and then specify 71.67, right? 71.67. 676. Okay, so that's your modulus. And then sorry, your modulus and do we have bulk modulus and share modulus? So we put in the value of share modulus. Share modulus is 7. Oh, something is wrong here. Um, Gigapascal, we have 7.16. Okay, share modulus is 26.928. Share modulus is 26 point. Let's check the unit gigapascal as well. So change to gigapascal. 26 26.928. Okay, so compressive yield strength. Compressive yield strength is in megapascal. That's yield strength, and it's 231.66. So change this to megapascal and write 231.66. So what else do we need? If you want to do thermal analysis, you will need thermal conductivity and query of thermal expansion. So if you need to do thermal analysis, let's put thermal conductivity. When do we get that? Thermal conductivity. Melting temperature, you can as well put melting temperature. It is temperature of what? Aluminium. Melting temperature, let's say 610. Melting temperature, put melting temperature there. Specify it to be 610 or 603 because of impurity. 0.9. Okay. So do we have anything for thermal? Thermal here. Do we have any thermal here? Do we have any thermal? So you can go back to project and update project. So that has been saved as a material. For thermal analysis, if you want to do thermal analysis, you will need um, linear expansion, thermal conductivity. So you can take steady state thermal, bring it here, all right, and then so you can link the materials together. Let's see, it's not there, so go back. So we are sharing data now. So now we should be able to see something on thermal. Okay, thermal analysis. So we take isotropic thermal conductivity and then we put the value. Thermal conductivity here is 149.49. Check the units. The unit is what? So 149.49. So any other property you want to put there, you can actually just add it on that material. So this is A356 1%. This is how you add a material to Ansys. Thank you. for watching. See you some other time. Please don't forget to like the video, subscribe, and drop your comment for more. Thank you.